Hi everyone, myself Shinde Sagar. Special thanks to Professor Khamkar UB for giving me an opportunity. So today we are going to learn about slope and deflection in the subject theory of structure. Introduction. Wherever a beam is loaded transversely, then a beam undergoes deformation. Deformation in the beam due to transverse load is called as bending. A simply supported beam is subjected to sagging moment and a cantilever beam is subjected to hugging moment. A beam is assumed to be made of elastic material, therefore, bending action in a beam is represented by an imaginary curve called as elastic curve. So, student, in this slide, we are watching a simply supported beam with a elastic curve which is loaded with the load of W at the center of a beam, in which a distance between beam and elastic curve is represented by a letter y, which is also called as deflection, and a tangent drawn through the elastic curve is called as theta and also called as slope. And this elastic curve is due to the bending of beam which is loaded with a load W, and this is also called as elastic curve. Deflection, a vertical distance between a point on a beam and its final position on elastic curve after bending is called as deflection, and it is denoted by y. In a below figure we can see the deflection of the simply supported beam by the load W, and it is denoted by y. Definition of slope. If we draw a tangent at a deflection point on elastic curve, the angle made by a tangent at elastic curve at any point with the beam axis is called as slope, and it is denoted by dy by dx is equal to theta. As the shown in figure, a tangent is drawn through the elastic curve which is denoted by theta, which is nothing but the slope of deflection of a beam. Boundary or end condition for a simply supported beam. When a simply supported beam is loaded with a load W at center, then a support reaction at support A and B are deflection is 0 and theta is max at support, and at the midspan y is max and theta is equal to 0. Same as the boundary or end condition for cantilever beam. When a cantilever beam is loaded at overhang portion with load W, the boundary condition will be at support A y is equal to 0 and theta is equal to 0, and at free end y is equal to max and theta will be a max. Differential equation of slope and deflection. EI is into d square y by dx square is equal to mx, where E is equal to Young's modulus, I is equal to moment of inertia, EI is equal to flexural rigidity, mx is the discontinuous equation, moment of force about point at a distance x from origin, d square y by dx square is equal to double derivative of y with respect to x. थँक यू. किती मिनिटाचं झालं? 4 मिनिटाचं झालं. वा, बघू आता.